Welcome to the next section. We're now talking about classification and regression with neural networks. We start this section by discussing the Perceptron, an online classifier that also serves as a building block for neural networks. Next, I briefly discuss the idea behind neural networks, including the different types and what the multilayer perceptron is. I show how to train a neural network for classification. Then I show how to train a neural network for regression. Let's start talking about perceptrons. In this video, I will discuss the perceptron algorithm, particularly as an instance of online learning. I give a demonstration of training the perceptron and show what online training looks like. The perceptron classifier on the surface resembles SVMs. It is a linear classifier and predicts that all observations lying on a particular side of a hyperplane belong to a particular class. But perceptrons are not SVMs. They do not try to maximize the gap between classes, and they are not designed to train data in a batch, where all data is received at once and no future data is used. Batch learning uses all available data for training at once. The classifier fits data the best it can. All algorithms we have seen used batch learning, and online algorithms do support it as well and often start out being trained by batch learning. But online algorithms can also update themselves as new data comes in. If an incorrect prediction is made, the algorithm uses the error to change the classifier. There are some advantages to online learning. One is that with online learning, the learning process doesn't end. The classifier adapts itself based on the feedback it receives. Another advantage of online learning is it allows for training classifiers on big data sets that don't fit in memory. Data can be loaded in when needed and fed to the trainer without loading in all the data at once. So let's see how to train a perceptron using scikit-learn. We're going to load in the perceptron object, which is used for training perceptrons, along with some of our favorite helper functions like train test split, accuracy score, and we're going to be training this on the iris dataset. We are going to train our algorithm to predict species from the iris dataset. Now, the way I described the perceptron algorithm, you'll notice that it only allows for binary classification. In scikit-learn, it supports multi-class classification using the one versus all approach. So it can predict, using that approach, one of three species. So let's load in our data set. Here's going to be the first 5 rows of the data set and the first 5 species class. In the training set, I've actually split the training data twice, you'll notice. We have data in, data out, species in, species out. The reason why is because I want to demonstrate what online learning looks like, the ability of an algorithm to update with new data. Let's create a perceptron and let's fit it on this first training data set. And let's see how well it does on that training set. And it's able to predict 67% correctly, which is okay, I guess. Now let's see what online learning looks like. So here is how our algorithm does on out-of-sample data, the second training data set. Not bad, about the same level of accuracy. But we can go ahead and fit our algorithm to include the information in this other data set using partial fit, which is a lot like fit, but updates an algorithm rather than replacing the fit. Now let's see how well it does on this training data, about the same. Now let's see how the algorithm does on the entire sample. So it has an accuracy of about 67%. It seems to be pretty ornery about that number. It seems to like 67% as its accuracy. So I'm pretty sure that when we go to the test data, it will have an accuracy of about 67%. Yeah, that's about 66, 67%. So we did see online learning, and we can see how we can use feedback to improve our algorithm. Perhaps we have a website and we're trying to predict whether a customer will go add something to their shopping cart or not, and we can actually update our algorithm as a person goes to their shopping cart or not, as it's making its predictions. And another thing that it will be able to do is scale to very large data sets, because you can load in principle, some of the data, update the algorithm, load in some more of the data, update again.